Okay, so on the bench here today we have a Kenwood TS 530S. I don't know if I'd go as far as to say I'm doing a restoration on this for the customer, because he didn't ask for anything cosmetic. He just wanted, which actually doesn't really need much other than just clean the faceplate, which I'm going to do anyhow. I always clean, just give him a good general cleaning. But he wanted all the maintenance done on this, so he wanted a full electrolytic capacitor replacement done, which has already been done. So here's all of the old electrolytic capacitors. He wanted a transceiver alignment done, and anything, maintenance-wise that I saw that needed to be done, stuff that might need to be done inside, go ahead and do it. So, basically what I call the 100,000-mile tune-up. Now, have already, I don't know if that video will get uploaded before or after this one, but I'm going to do a separate video on shaft couplers. Now, the shaft coupler has come back to bite me in the butt. So let me cover that really quick, what I found. So when I first got this radio, I never plug them in. I always, try all the controls first, unknown, because these are high. You got to remember, a lot of juice inside of these things. There's, once you flip the power switch on, there's over 900 volts in this compartment right here. Matter of fact, if I grab the cover, you can see it even says, danger, high voltage. They're not shitting. There's high voltage in there. It's over 900 volts. So once you flip the heaters on and you're ready to transmit, it drops down a little bit. So this one idles right around 918 volts in ready to transmit mode. So be forewarned. If you're don't feel safe working around high voltages, you can either stop the video now or just keep watching out of curiosity. But yeah, don't mess with things. If you're not safe working in high voltage areas. Now, the advantage of this is once you turn the radio off, and of course always unplug it, the high voltage caps in this do automatically discharge. Now, it takes a little bit of time. Now, we're not talking days or even hours. Fairly short duration of time. The high voltage caps in this will discharge. Now, I changed the high voltage filter caps, actually the doubler circuit in this. Now, when I change these, it's just, instead of trying to get these ceramic caps off and these bleeder resistors off, I just leave them on and install new ones. It's those two little parts. It's going to cost more in labor for me to try and get them off, get the leads straightened back out, get them attached to the new ones, than it is just to grab brand new ones and stick them on. So that's what I did. So kind of convenient. I can show you. So they do have resistors there. So these are, 47, or about 470, yeah, so 470,000 K resistors in series, or in parallel across the caps. So as soon as you power this thing down, if you hook a voltmeter up to these caps, you'll see the voltage immediately start to drop. So it does drop. But best thing is, if you're unsure if your caps have discharged and there's any high voltage in here, when you take the cover off, it's real simple. Clip your voltmeter negative lead here, touch the positive right here. If there's high voltage in this thing, you'll have high voltage here. Actually, you'll have high voltage all throughout this area, but this is a convenient place to test, is right here. Now, as for my problem, this shaft coupler, when I first got this, before I even took the covers off, I turned all the controls, pushed buttons, flipped knobs and switches, see how everything feels. I got to the load control, I turned it, and I got to about the last quarter of rotation. Now, it only turns a half a turn, but about the last quarter of that, half rotation, it went, it was like, so I thought the potato slicer, or, the air variable cap here, something happened drastically wrong with it. Either somebody bent the plates, or worse yet, something had arced somewhere in here and burned the plates. As soon as I got the cover off, I was pleasantly surprised to find that this shaft coupler was split, and it had a hose clamp on it. Hose clamp, when all it was doing was coming around, hitting this tube shield here, and that was rubbing. So I replaced it. That's a whole nother video. Now, I should have known when I saw this coupler broken on that shaft, there was something wrong. If this coupler is going to break, it is usually the one down here. The band switch, okay? That shaft runs the whole way from your band selector switch through all these wafer switches. Okay, that's this shaft right here. It also runs in, and there's 3 sets of wafer switch contacts on the inside here. But that's a separate that's a separate switch assembly, and it's attached with another one of these exactly like this. That's usually the one that breaks. So, my problems. I've recapped it, powered it up, and I'm not even going to try it out. I just recap them first, because a lot of times any problems you have will go away with a cap job. They're old, they're getting worn out. You can get all kinds of weird problems when electrolytic caps start to short out internally and leak. So I did that. Get the radio powered up. Yeah, power is just not right all over the place. I can't get the right power out. It varies. It's just, yeah, there's something just ain't right with this picture. And it was band dependent, which usually is an indicator there's a problem in here, not your tubes. Now, if you just have low power, yes, it can be tubes, can be lots of things that are common. A couple of these caps, little chokes down in here can cause low output problems. But of course, tubes, your driver tube. But when you have band-specific power problems, that's usually an indication of problem somewhere in here in the switching circuit for all of the capacitors. So you have two air variable capacitors, you have the load and the plate controls. Now this is all of this in here basically makes the resonant circuit for your final tubes, okay? Now there's a coil here that has a bunch of taps going off of it for each of the different bands. And depending on what position your band selector switch is in, that picks which combination of capacitors down in here are attached, how many sections and in what bands, because this is a 3-gang air variable capacitor here. It selects which and in what modes each of those gangs is in, because in some bands, or in all bands, one of them's in some bands, 2 of them are in, and in some other bands, all 3 of them are in parallel. And then there's another wafer switch that selects how many windings off of this coil here are actually in the circuit. And so if you ever run into it, but what I've found is the light bulb has gone off. Someone screwed me. And what I mean by that is, yeah, this one doesn't normally break up here. So that's actually probably what happened in this radio, because I can now now that I'm looking for a problem, actually I know what the problem is, but I get to looking, I can tell this one is actually the one that used to be down here. Somebody took it out, put it up here, put a hose clamp on it, because they could fit a hose clamp on it up here. Where down here, inside of the PA cage, you cannot fit a hose clamp in here. There's just no room. Besides that, it would be next to near impossible to get in there to stick a hose clamp in the first place. They moved the bad one up here, moved the good one down here. The problem being, they put the switches out of orientation. It's in the wrong damn position. And now, that's not the only thing that can cause that. You can have some of these capacitors can go bad and can cause that. So I'm going to make a short video on that. Troubleshooting the final section in this, and troubleshooting basically your resonance circuit, and what actually switches in and out. Now, as far as coils go, yeah, they're either good or bad, and it's going to be blatantly obvious if you have a problem with this coil, because it's just a piece of wire wrapped around a coil form. If it's good, it's going to look like it does in this radio. It's going to look like a piece of wire just wrapped around a barber pole, basically. If it's bad, it's going to be blown in half. It's, piece of wire only has 2 states, basically, as far as a coil is concerned. It's either attached or it's disconnected. And if it's disconnected in this, that's because it's something arced or, flashed over, burned in half. It'll be really obvious. So that leaves us with something, the capacitors. And those can go bad. And they do. And actually, this one down here at the bottom of this coil, you have one here at the top, one at the bottom, and a little small choke over here. But this one, I can actually see there's actually a crack in the top of it. But there's a bunch of them that are actually switched in and out depending on bands. So if we look at that on the schematic, so here's actually a printout of the schematic. And the area of the circuit that we're concerned with is right here. Because this is where the capacitors are right here. All of these capacitors right here. One up here, and then as far as the actual air variable capacitors are concerned, this is the 3 gangs, one here, here, up here, and then there's one over here, which is your plate control. So now I've blown that up so you can actually see it. So that would be this one right here. So grab my other little notebook, get that ready. So let me just set this up here, move the camera a little bit. So an easy way to diagnose if you're having a problem, let's get something pointy so my big fat meat paws aren't in the way. Now for starters, on this schematic, the wafer switches are shown in the 1.8 megahertz band position, okay? And then, rotating clockwise, you're going up in frequency. So I actually marked them on here, 1.8, 3.5, 7, 10, 14, and on around. Now there is a missing position on here. There's 11 positions, and the wiper, this is actually a 12 position switch in this radio. So the switch can be moved, and I'll turn the radio around once I get done describing what I'm showing here. When I actually go to take measurements, I'll turn the radio around and show you the band selector switch to show you what I'm talking about. But there's one basically unused position on this switch that's not shown, indicated here, and they don't show it because it's not used. But so what we have is there's two sets of capacitors that get switched in and out. There's all of these and over here. So we have two separate circuits, the load and the plate circuit. So what we want to do is isolate this circuit so we can actually test the capacitors. And I don't mean actually going in and testing each individual one. We want to basically be able to measure the capacitance across the entire circuit. There's an easy way to do that. Now, without pulling out the manuals for every specific radio, I can't be 100% sure, but the final circuit and all the Kenwood hybrids, it's pretty much exactly the same. But the part numbers may be different. I can't be 100% sure, like I say, without going and pulling all of them. Now, this is actually the schematic for this radio, a TS530S. So there's several other hybrid radios. If you look at the schematic, it's going to look exactly the same. All the capacitor values, all the parts, they're going to be exactly the same. It's just the part numbers might be different. So in your case, depending on what radio you're working on, the part numbers might be different. But they might be the same. Like I said, I just can't remember if they are same or different. So what we want to do is isolate this circuit. So we're going to want to remove, in this radio, R24. So you're going to be, and I'll show you the three parts. So you really don't even need to know the part numbers. I'm going to show you where they are down here, and I actually have them marked with these little wire clips. But you're going to remove, or you don't have to completely remove it, but you need to disconnect one end of it. So you need to disconnect one end of this 10K resistor. You need to remove one end of coil L5, this 470 microhenry coil. And you need to disconnect one end of capacitor C7, which is a 0.001 microfarad cap. Now the easiest way to do that is remove the tubes. Actually, you don't have to remove the front one, but remove the rear tube and remove the fan. Makes it very easy because the fan, when it's in there, you've got the motor, the coil and everything's kind of in your way here. So capacitor, try and get this in picture here. So this capacitor C7 right here is a 0.001 microfarad. It's a 3 kilovolt cap. That's what this little clip here. So I'll take this off. So this one attaches right here. Attaches to this point right here on top of this coil form. You'll see you have these go over to the tops of your tubes. That's where this capacitor, it's in between this air variable cap and this connection right here. So just touch that with a soldering iron. Lift that off. You want it disconnected. I'm going to need a little bit of supplemental light, I think. The 10K resistor, I'm going to grab my paper again here. This 10K resistor right here, it's a 1 watt. That is too much light. This resistor right here. So you're going to be looking for a resistor. Though if you're doing this, you probably know electronics. I don't need to tell you the color bands, but it's brown, black, orange. So I have this little clip here. Get that pulled off. So you can see one end of that is disconnected, okay, from this point right here on the terminal strip. And then the last thing we want to disconnect is one end of L5. And I just disconnect the ground end of that. So that's this last little clip I have on here. And that will be, I'm going to slide it out of the way, that's actually attached to this ground lug that sticks up off of the chassis. So disconnect that. Now, once you have those 3 parts removed, we can measure the capacitance of the entire circuit, and then we can see if we were having a problem. Maybe capacitors are bad or whatnot. So what we're going to attach to, and you're going to need a capacitance meter, but you're going to attach from ground, so in this case I can just clip onto the chassis right here, and this point right here at the top of the coil form, most convenient place to grab onto, it's right there. So actually, let me get the radio. Well, I don't really have to spin it around. I'm sure you believe me, actually, once we get everything done, I can show you that, how the heck I'm going to get this set up in here, though. Huh, actually, it might stay there. Of course, I got to get the clips hooked up here. So what I found was my measurements were all wrong. Oh, just look at that lovely glare. Oh, for Pete's sakes. Wrong button. Hey, now you can see it. Of course, that's going to time out after a while. But what I've done is actually sat down. Actually, we can just turn this off. Let me show you the chart that I made up here. So, as we're going through, these capacitors get switched in and out. These capacitors get switched in and out. Now also your coil, because actually here's the coil. Remember I said it gets switched in and out. So you have wafer switch here and here. So you see those get switched in and out depending on what band it's on also. But we're not worried about that. It's wire. If it was bad, we would see it. We're worried about these caps. So I made up a little chart here. Okay. Now this little chart. So actually if you want to freeze the picture, you can pause it. If you ever want to work on one of these, you can copy this. Save you from having to sit down and go through and, let me slide this back in here real quick. Sit down, figure out the capacitors and which switch position, which capacitors are in or out of circuit. But now this one is always in circuit, so you can see all of these capacitors here. This is the white, this is the main center contact, so this one's always attached. Now we've disconnected this end here, we've disconnected it over here, and you can see this. Now this is the load control. There's 3 sections. 2 of them are switched in and out. 1 is permanently attached. Now those are 430 ohms each section, I think. Let me check my chart. Yeah, 430 ohms. So that is always in circuit, and this 100 picofarad capacitor here is always in circuit. So at a bare minimum, just right here, you always have at least 530 picofarads in circuit. And then depending on your switch positions down here, that'll vary. And then same thing over here, you're going to have your plate capacitor is always in circuit, which that one is, 220 picofarads. And then in only 2 modes are these capacitors in circuit, the 1.8 and 3.5 megahertz band positions. So this top one and this bottom one here are in parallel, and then this 100 picofarad. So that's what this chart is reflecting though. So for each position, so like in the 1.8 position, the capacitors, because remember there's 3 sections, so you can see this is where one section is switched in. When we switch in another 430 microfarad or picofarad section, it jumps up to 860, which is 2 times. And then if we add another 430 picofarads to it, we jump up to 1,290 picofarads. These are the actual capacitors, or how much capacitance is actually here is grand total. So if you add, because remember capacitance adds in parallel. So depending on how many of these are in parallel, that will add or take away to this right here. Same thing with the plate. Now the plate is always at 220. It's a single section air variable cap, and it's always in circuit. And then only in the 1.8 and 3.5 megahertz positions do we have any added capacitance to the plate. Now this is the number we're concerned about. So all this number here, the total, is just add straight across. So add 1,290, 3090, 220, 512, you end up with 5112. You know, the same thing goes here, 1290, 1150, 220, 100, comes up with 2760 picofarads. This is what we're going to be measuring. That's what we're looking for. If this isn't right, we've got a problem. So, let's get set back up here. You might be able to see it right there. Okay, so let me get in the auxiliary position. I'm going to try and set this in here. Yeah, there we go. So we're in the auxiliary position. Actually, I need to get the capacitors all meshed. Now, when you take this measurement, you need to make sure both of these capacitors are fully meshed. So the load control fully meshed, and same thing with the plate control here. You want to make sure you have it fully meshed as well. So you can see we have 750 picofarads right there. And if you look across here in the auxiliary position, we should have 750 in the auxiliary, 29, 28, and 24 position. So I'm in the auxiliary position now. I'll switch to 29, 28, 24. Now if I switch to, let's see, am I in 20? Yes, I'm in 24. So you can see we're still at 750. Now I'm going to switch to the 21 position. It should jump up to approximate. Now these are approximate. There's going to be variance in the tolerance of the capacitors, but you can see we're really close. I should flip up to 1180 when I go to the 21. I just switched to 21 and we're still showing 750. Something definitely is not right here. If I switch to 18, again, we should have approximately 1180. Aha! 1159, 1160. So yeah, that's close. That would be about right. If I switch to the 14 position, I should have 1610. It didn't change. We still have approximately 1160 picofarads. But did you notice? That's two band positions should have that measurement. But now it seems to be down here. And again, if I go to 10, so now we're in the 10 position, we should be showing 1610, which that's off some, 15,570. If I go to the 7 megahertz position, we should go to 1880. It didn't change. Again, these two 1610 positions seem to have slid down one notch. If I go to the 3.5 position, I should have 2,760. 1826. Well, that's what you're supposed to have for 7. And if I go down to the 1.8, we should have 5,112. And we have 2,727, which is very close to 2,760. Now here's the kicker. If I go down to the completely unmarked or straight down position, which is completely unused in this radio, that is the straight down position. 5,071. 5,112. Aha! The rotary switch is in the wrong. It's when someone put that little flex coupler right there. If I turn the control, you can see it spinning around there. They put it in the wrong orientation. They're off one notch on the channel selector. But like I said, I wanted to show this. So if you're having problems, because that's not necessarily your problem, that somebody has reassembled a radio wrong, but if you need to troubleshoot those capacitors without having to actually physically disconnect each one, because that's going to be next to damn near impossible to try to remove. It's just going to be a pain in the butt. It's so much easier to measure the total capacitance of basically the entire circuit and just get a measurement of that and use this little chart. So, again, if you need to pause the video to write that down, hold that there for a second so you can hit pause. But just copy that down, and you can use this as your baseline. Like I say, these could be off 20, 30 picofarads or something, whatever in either direction, but it should be fairly close to these readings. So, yeah, that apparently appears to be my problem. amongst other things, because actually the 14 megahertz band, I'm having problems with that one. I fear it might be a wafer switch problem, which in these radios is not another one of those. These do have bugs, they're known. Shaft couplers breaking, very common problem. Another common problem in these, all of these wafer switch elements up here in the front. But if you notice, they're not made like these here. These are just, round. They have the contact points on there, but the wire actually solders, or lead of the capacitors or whatever, are soldered right to the little spring fingers. They're soldered at one end, the spring fingers are at the other end. These are not like that. These have the little spring fingers, and it's riveted to a circuit board, to a piece of, there's no solder mass, so it's bare copper, the contacts, and then they rivet it down. And then the circuit trace runs down, and then each of those little boards is then soldered down to the main circuit board down here. The problem is corrosion. And this one, I can see almost every single rivet in this thing is slightly green, and you can see some of that copper trace underneath each one of those little pads is slightly green as well. And that's another common problem with these. You end up with intermittent problems where with a band missing, either receive or transmit, because it can be either or, because there's a lot. There's what, 1, 2, 3, 4, 5, 6, 7 different wafer switch sections here. But you can lose one, the other, or both if you lose contact with those. Yeah, it's not the easiest thing in the world to fix, because you have to pull the board out, then you have to dismantle, take take the shaft out, take everything out. And dismantle it, progressively, depending how far back in you need to get. Desolder the circuit board, take it out. Now, the easiest way to fix those is, in my opinion, I know some people will use the conductive glue. I'm not a fan of stuff like that. That's just not permanent enough for me. It might be fine for fixing your kid's Atari or Nintendo, but when you're working on a radio, you want a good, solid connection. Best way I've found is just scrape off a little bit of the solder mask on that circuit board, clean, take like a fiberglass brush, clean the back side of that brass contact, the little spring finger contact back here, clean it off really well, and solder it fast to the circuit board. Some people will actually put a piece of wire through it down to the board. Whichever you do is fine, but that's probably the most durable way of fixing it. So, like I say, I thought I'd show that, and actually let me get the fan at least partially stuck back in here, so it's not flopping around. Just get one screw temporarily stuck in here to hold it. Oh, come back here, little guy. There, that'll keep it from falling out of the radio. Now I can get some of this stuff out of the way and turn this around. And I'll show you what I mean by the band selector switch. Actually, let me get my meter hooked back up back here. Kickstand up on it. So you can see this has, we just need to tilt the radio up slightly here. So you can see the last position there, an auxiliary, but there's a spot in the middle. And actually you can notice the knob's not quite straight up and down. Same thing when you're on 18. It's kind of cocked off to the side a little bit. So yeah. But when I'm in that middle straight down position, that's when we have our 5072. I flip back, switch over. That's what it should actually be showing. In that unused position, it should show the same thing as you do in auxiliary 29, 28, and 24.5. But yeah, so somebody has the shaft one notch out of orientation, basically. And even with a little bit of further inspection, just looking at things, I did notice, let me try and get the camera down here a little bit. Yeah, you can kind of see it. but if you see that dark line right there, that's actually where that shaft coupler used to be riding. They have the shaft coupler back in about a 1/4 inch farther than it originally was. And you'll never be able to see it, but when I was looking in through the side, I can actually look through these slots in that coupler that's in there and see the impressions of the set screws where this shaft coupler has been pushed back farther. So, you know, the impression that, let's say, this set screw made when they got the other coupler in farther, I can now see it. So, yeah. But, so that's just how to do some basic troubleshooting of your PA section, because there's really not a lot more back here. You got a fan, has nothing to do with it. You know, it's basically all capacitors and inductors. Like I say, if it's an inductor's bad, you're going to notice it. It's going to stick out like a sore thumb. There's a couple resistors and chokes down in there, but the large majority of your problems you're going to find are going to be capacitors. Now, usually this one here, actually this one that you'd be disconnecting, and the one right below it, which is the big blue one, is a 0.001 microfarad. Those commonly fail. Those are, I recommend always replacing those. That capacitor, the capacitor down there, and then there's a little choke behind that little green guy, kind of looks like a resistor. You should change all 3 of those. This capacitor has full RF power going through it, so it takes a beating. Now, it's a 3 kilovolt. Easiest thing to do nowadays is you can get, like if you go to RF parts, you can get like a 5 or a 10 kilovolt doorknob style capacitor. It's a ceramic cap, but it just has the leads come out either end of it. It's not radial like this, so it's more like an axial. They fit down in there just perfectly. So there's just some tips on troubleshooting the PA section on a Kenwood. And like I say, that doesn't hold true just for this radio. Pretty much all the hybrids, this is almost exactly the same. The part numbers, like I said, I can't be 100% sure without pulling out other schematics and looking, but they might be a little bit different. But the parts are going to be the same. So the capacitor values, all of that, that's all going to stay the same. So I hope that helps somebody out. And if anybody else ever gets a radio where somebody did what somebody did to this one, took out a broken coupler, moved it up here, moved the good coupler down there, and then didn't get it reassembled right, you know, this is the easy way to find out. Like I say, just disconnect 3 parts. You can hook up a capacitance meter here. It allows you to not only test the band positions, but you can pretty much test each of the capacitors, because by doing this, now some of them are always connected. So these 3, as you can see, they're always connected in parallel. But if any of those are bad, you know, you'll notice that when you're in this position here, that's the only position those are in. Same thing if you have a problem with one of these 2. You can see that's only used in this position. You know, so as soon as you flip off of that, if you flip 2, and actually I put this little orange dot here for a reason, because as this wafer switch, like I say, this schematic is laid out starting here, and as you rotate around that, I'm actually highlighted that with a little bit of orange. That's the section you'd be watching go around. So if you flip it you flip your band selector switch 1 notch clockwise, it's going to go to that orange is going to slide up to this contact, and then to this one, and this one. And you notice there's a big opening here, so it's not going to be attached to anything. But that's why I put that on there. So just something to be aware of. If you have problems, that's an easy way to test these parts. Disconnect this resistor, that coil, that capacitor, then you can just measure basically the capacitance of the entire circuit. Just makes it a lot simpler. So there you go. Hope that helps. So I got the radios, at least the PA final section stuck back together. Tried tuning it up on all bands. Works so much better with the front and the rear wafer switch section in the proper orientation. Yeah, that was the entire problem with this thing. So you can hear it's actually hooked up to an antenna now. Dusted off one of my bench Kenwood speakers. You know, always look at it this way. If you're going to listen to a Kenwood, you might as well listen to it on a Kenwood speaker. Working on Yaesus, I dust off a Yaesu speaker. Working on a Heathkit, you break out a Heathkit speaker. So, like I say, it does work.
vehicle with tri-band radio under it.
I'll shut up and give it back to you, Brother Jim. This is...
So a little bit's coming in on 80 meters.
42, I think, this morning. And we're supposed to have that 50% rain tomorrow, I sure think. Now they're giving maybe this next weekend we may have some snow flurries up here, so...
I remember I need to take some medicine for the evening. I forgot to do that.
Yeah, man, it's working, man. I'm surprised que tú me estás dando 20 over, you know, with only 80 watts. So...
Cleansing breath on the way to the coffee pot.
And that's something to remember when you're using one of these radios. As you tune across the band, you're going to need to readjust your drive control because you can hear. So it's not like a modern radio. You just tune the dial and yeah, your reception stays fairly level the entire way across. It's a lot of tuned circuitry in here. It's done old school way because this is this is a hybrid radio. So you're going to need to adjust your drive, and then when you go to transmit, you're going to need to retune your transmitter. Let's say this frequency is a frequency you find a QSO going on that you want to jump in on. You're going to want to tune in on this frequency now. But if you adjust for maximum receive sensitivity, that's going to get your drive pretty much dead nuts on. Then the only thing you should really have to worry about is going to be your plate and load controls, just fine tuning them. But the drive, like I say, as you tune across the band, you're going to notice your reception or the volume's going down, 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 and you're going to have to readjust the drive for maximum volume.
No, there's no covered bridge at Spring Mill. They've got the old mill house down. They got an old settlement town. We might have been through there. I just don't recall it exactly by name.
So there you go, though. So like I said, it's one thing to remember when if you ever have to change one of those couplers. Like I say, and I'll have to put this one in my memory banks. If I ever see that one right there broken, yeah, it probably didn't break. It broke down. That's the one that broke, and somebody swapped them. Is a really good chance. I just need to put that in the old memory bank so I don't get bitten by this again. But like I said, I wanted to show how you can go through and check pretty much all of the capacitors in the tuned circuitry of the final section just by disconnecting 3 components, and you can hook up a capacitance meter and measure the entire capacitance of that entire circuit. Just makes it real easy for troubleshooting. And I guess a tip I could say on if you do change this coupler, now the shafts have flats on them. The rear switch is actually a switch with 3 sections, and it has its own little shaft. And then each of these switch sections up here are all controlled through this front shaft that runs the whole way to the back, and actually just slightly inside the RF cage back here. Now it has 2 flats, and then it's like a half moon on the other sides of it. The one in the rear section has 4 flats. Now, when it breaks, try to make sure that you line up the set screw holes, because we're not so much the set screw holes, but there'll be impressions on the shafts. So just like in the case of this one, you can see those two holes, the hole in the front and the hole in the rear of this coupler, they're perfectly in line. So when you go to retighten your set screws down, they're actually before you push this front shaft in. So you pull the shaft out, you've taken your old coupler out, you've stuck your new coupler in. Make sure you note in orientation where there'll be a little mark on the shaft where that original set screw was tightened down on the shaft. Make note of that in orientation, a mental note where that notch is, or that little, basically where it scratched the surface of the shaft on the rear section. Put your coupler in. Try to line up the set screw with that mark, and then slide your front shaft back in, and make sure the same thing, that you get that deformity, I guess you could call it, where the set screw has marred the surface of the shaft. When you push it back in, that it's also in line. When the person put this one back together, if they'd paid attention to that and made sure that those two spots were perfectly in line, they would have also noticed that the flats of the shafts were in line. So one wasn't like this and the other one, and that's why it was just all screwed up. So there you go. There's just a few little more tips. I just want to show it is back together. It does work. So now I can get on with the alignment. Frequency's off a little bit. Yeah, the transmit section, I think somebody actually did that. I don't want to say they golden screwdrivered it, but they knew they were having problems. They tried adjusting some of the coils for output power. So, and I've actually just, I want to say by ear, but by eye, I haven't actually done an alignment, but I did notice the power was down a little bit, just a little bit of tweaking, and the power was coming back up. So I think they probably got it out of whack. They didn't know what had happened. They tried to adjust some of the RF coils, and they ended up making things kind of worse. It may have improved it for them, but once the switches were put back into proper orientation where they're supposed to be, it threw that out of whack. So, like I say, just a few more tips if you ever have to change one of those. Just be careful. It didn't hurt the radio, but yeah, it definitely hurt performance.